first project for advanced technology. The given topic was accessibility. This prototype demonstrates the benefits of voice commands to substitute gamepad inputs for people with motor disabilities impairing their dexterity and reflexes. Principles of universal design informed project features and widened the potential user base. So let's get into it. Afflictions of the upper limbs make up a large portion of gamers who identify as disabled. These conditions can prevent people from enjoying games by limiting the dexterity to use a standard game controller. While specialised controllers do exist on the market, different features of a disabled person's condition can prevent one controller from appealing to all who need it. High cost of hardware and a lack of market knowledge have been cited by people needing assistive gamepads as a reason why they aren't being used. By using voice commands for game input without needing any gamepad, these issues are circumvented. The only required hardware is a microphone, which is more accessible and general purpose than a specialised gamepad, not to mention more likely to already be owned by a gamer, as voice chat sees major use in games today. With the hardware chosen to explore, it was now time to design a game that best demonstrates the inclusivity potential. Here I am in a build of the prototype. Let's demonstrate the controls. Down, down. Up, up, down, up. Confirm. Fish. Bumper, south. Up, banana. Shoulder, west, banana. Right, trigger. On the left is all the input commands and the custom terms currently set for them. Right. These controls work with the gamepad as well as the voice commands because of the universal design approach. This is the concept of giving an experience equal access to as many as possible. This can help normalise disabilities through shared play experiences. The input matching arcade gameplay was inspired by rhythm games like Vib Ribbon and Beat Saber. It's a simple method to demand the use of as many different buttons as possible. This creates a constant need for dexterity, so a situation where a disabled user would benefit most from voice commands. To achieve the voice commands, Microsoft Azure's speech recognition kit was used. This supports continuous listening and multiple regions for speech, in keeping with the universal design ethos. It also has native support in the Unity engine, and is poised to build the game in Unity. The only problem with Azure is the demand for constant internet access to use the cloud service. However, this impact is lessened by the popularity of online games among disabled people. West, banana. This is the options screen. This allows setting of the speech region, recording custom speech terms, and clamping the maximum game speed if the standard speed is too high. For consistent settings over multiple play sessions, all settings data is serialized to a text file for external saving and loading on launch. To help scrolling navigation, drop and rise commands jump through many elements at once. Now let's break down the input process. First, speech input is returned as a string of text, from which multiple commands get extracted to reduce latency. The string is standardized and split into individual words. It is set to lowercase and punctuation is removed for consistency. Then, each word is checked for an exact match to a known command, and any matches are added to a queue for in-game execution. To allow terms to change at runtime, a dictionary stores the currently used strings and pairs them with an enum representing the command type. While the project is fairly robust, there is room for improvement. The font used limited the full support of all possible regions, as it can't display characters outside the Roman and Cyrillic alphabets. This could be fixed by updating the displayed font at runtime corresponding to the active language. Another limit is the lack of non-English translation for the default speech terms. This undermines the goal of universal design, as a non-English user would be unable to operate the software as effectively as an English user. However, the option remains to record new speech terms replacing the defaults, provided UI navigation is possible. Overall, this project showed a successful demonstration of voice commands as an alternative to gamepad input. The gameplay serves as a suitable demonstration of a situation where speech commands are useful by demanding quick and varied button input. The option settings are polished and aid in the philosophy of universal design by catering for a range of accessibility options. Thank you for watching. The second project had the topic of games for public spaces. This prototype aims to achieve an online multiplayer game framework where the game is accessed through a web browser on a smart device. social rituals were studied to inform a game loop with a boss battle to demonstrate the social applications of this technology. So let's get to it. In recent years, social spaces have been reshaped by the increasing presence of multiplayer gaming in social venues. Since 2018, the UK has seen a 40% increase in these types of entertainment sites, growing to nearly 600 and expected to exceed 800 by 2029. This ties in with changes to consumer habits. Notably, a decline in alcohol consumption among young adults is causing a steady decrease in the number of pubs nationwide. Another factor was the COVID-19 pandemic. With lockdowns causing widespread isolation, many turned to online multiplayer games as a way to stay socially connected. Even after lockdown, demand remained high. The global market is projected to hit over $32 billion or £27 billion by 2027. Among online games, those with browser input stand out for accessibility. They work on virtually anything that supports a web browser, requiring no installation. This makes them ideal for casual audiences and public-facing interactive spaces like the one explored in this project. Here is a demonstration of player connecting. The QR code and URL both link to the web page controller, so joining is as simple as scanning the code with a smartphone, taking users to this page. Here, a name can be entered and submitted before an avatar appears in the game world. For casual players, the control was kept simple, with just 3 buttons, left and right, and a jet button to fly upward. For visual clarity, the colours invert when pressed. Projectiles are automatically fired every 0.4 seconds in the direction the player is facing. This frees players to focus on dodging hazards and working as a team. This game centres around a group of small player characters teaming up to defeat the giant skull. This format encourages collective player attention, which studies have linked to stronger social engagement in multiplayer games, like the raid battles in World of Warcraft. The chaotic nature of the boss battle was influenced by bullet hell games such as Cuphead and Vampire Survivors, where the screen is flooded with many different entities and attacks at once. Because of this, visual clarity was important. To make it easy for players to spot their character, each avatar is randomly assigned one of 10 distinct colour palettes when spawned. Players also have their name and health status presented above their character's head, cutting the need to track stats mentally and keeping focus on the action. To support multiplayer gameplay in a public setting, the project uses a client-server network topology. In this model, a single device acts as the host server while all other devices, the client, connect to it. This is very scalable, making it ideal for scenarios with many simultaneous players. It also gives the host full authority over the game state, letting them verify all client data to reduce the risk of cheating. Another benefit is security. Since clients only communicate with the host, they don't know or interact directly with each other. This limits exposure to other users of the network, which is especially important in public environments. Prototype was built in a single Unity project to keep things portable and limit the reliance on external tools. This project includes both the host game and an embedded server hosting the controller page. When the host starts, a WebSocket Manager script handles 2 tasks. It launches the embedded server for web page controller, and it registers a script to the WebSocket service. This other script, Input Server, handles incoming input messages from any connected clients. The finished prototype supports at least 8 players at once, with smooth and responsive input. No visible lag was observed, indicating that the core technical goal was achieved. One limitation is that all devices must be connected to the same Wi-Fi network, as WebSocket communications use local IP addresses that can't be referenced by the wider internet. However, it doesn't stop the intended use case, which involves all players present in the same location as the host machine. In such settings, a shared Wi-Fi network is a practical assumption. Looking ahead, the project's connectivity could be expanded through port forwarding. This would allow a router to redirect traffic from the wider internet to a private IP address on the host. That's all for this video report. Thanks for watching.